Hello and welcome back to the channel, or if this is your first time here, welcome. My name is Professor Adrivan, and this is episode 3 of the linear series, where we're going to be looking at solving one variable linear inequalities. As normal, we're going to be doing 3 examples in this video, and they're on your screen now. So if whatever problems you're trying to work through look like these, this is the correct video for you. So before we actually solve the one variable linear inequalities, we want to look at and make sure that we know what the inequality symbols are and what they actually mean. So we have the 4 inequality symbols written, each in a different color. The first one is greater than. So if you see this symbol, it always means greater than. The second one is less than. Now the other two look very similar, but there's a line underneath it. And the line just means that it could be greater than as well, or for the line underneath, equal to. And finally, the last one, following the same pattern, is going to be less than, or equal to. Alright, so we have the 4 inequality symbols defined, so we can use these in our problems to solve these one variable inequalities. So what do the problems look like? Our first problem is 5x plus 15 is less than or equal to negative 10. So these inequalities, solving them, it's very interesting because we solve them nearly identically to the way that we solved the one-sided and two-sided linear equations in episode 1 and 2. Right, we want to get all of the x's on one side of the inequality and move everything else to the other side. So this 15 does not have an x, so I want to move it to the other side. We're going to move it to the other side exactly like we have been. It's a positive 15. In order to move it, we want to subtract 15 from both sides. Right? 5x will come down. The symbol is staying the same, still less than or equal to. And negative 10 minus 15 is negative 25. To move the 5 that is in front of the x across the less than or equal to, we want to divide by it. Right, so 5 divided by 5 cancels out, leaving us with just an x. The symbol is staying the same, it's still less than or equal to. And negative 25 divided by 5 is negative 5. This is our final answer. Notice that we did it exactly the same as we did when this was an equal symbol instead. The symbol just carried through the entire problem. In the next episode of this series, we're going to be graphing these solutions, so be on the lookout for that. So how are these problems even different than what we did previously? Well, let's take a look at this example and find out. Well, we know that when we have parentheses and a number in front, we want to distribute it. I want to distribute this negative 2. So we want to do negative 2 times 3x is negative 6x. And negative 2 times negative 1 is positive 2. Everything else is going to drop down, so greater than or equal to 20. And then we're going to solve it just like we have been. I'm going to take this positive 2 that does not have an x, and I want to move it across the greater than or equal to. So to move it across, we're going to subtract it, leaving us with negative 6x is greater than or equal to 20 minus 2, which is 18. Alright, and here's where things get different. When we divide by the number in front of x, this negative 6, we're still going to be left with an x, and we're still going to have 18 divided by negative 6 is negative 3, but the symbol is going to flip, meaning instead of being greater than or equal to, it's going to be less than or equal to. So this is happening because of this. When we multiply or divide by a negative, we flip the sign, the inequality sign. Right, so when you multiply or divide both sides of the inequality by a negative number, it will flip the inequality symbol. So if it's less than, it's going to become greater than. If it's greater than, it's going to become less than. If it's less than or equal to, it's going to become greater than or equal to. If it's greater than or equal to, it's going to become less than or equal to. All right, the sign flips, and the or equal to will stay with it, right? So less than or equal to, if it's flipping, will become this, and less than, if it's flipping, will become this, right? Vice versa. All right, let's take a look at our last example. It doesn't matter what side I get the x on. Normally, I move the x's onto the left, but let's change it up a little bit. Let's move the x's to the right, just so we can illustrate something that's going to happen. So if I want to get all the x's onto the right, that means I want this negative 2x to go to the right, meaning I need to add it to both sides. So the negative 2x and positive 2x will cancel. That's what we want, leaving us with just a negative 5 on the left. Greater than or equal to, well, 3x plus 2x will be 5x and negative 25. I now want to move this negative 25, because he's hanging out with the x's, to the other side. Right? So we need to do the opposite, plus 25 to both sides. Well, negative 5 plus 25 will leave us with positive 20, greater than or equal to 5x. Our final step, divide by the number in front of x, which is 5. Well, 20 divided by 5 is 4. I'm not flipping the sign because the number that I divided by is positive. Right, so the sign is staying the same, and we're left with x. Right, so this is our final answer. 4 is greater than or equal to x. Now, some teachers will want you to always write it as x first. So normally if I have like 3 equals x or x equals 3, those are the same thing. It doesn't matter which way we do it. But I can't just flip this, right? These two are not the same. So we need to do something. We need to read this from x over. So I'm going to read it from right to left. This says x, and then this is saying that x is smaller than or equal to 4, because it's saying 4 is bigger than or equal to x. So the symbol for smaller than or equal to is less than or equal to 4. So if we're going to change the order that we write the inequality, the symbol will change as well. Alright, so in the next episode of the linear series, we're going to look at graphing these solutions that we came up with. So be on the lookout for that. If this video was helpful in any way, consider giving it a like and a sub. That would mean a lot to me. Thanks, good luck, and we'll see you in the next one.